Welcome to homework.
In this question, we're asked to evaluate some expressions to three significant figures and then make sure that we're using SI units with the appropriate prefix. So there's a couple things that we need to do here. We need to take care of the calculations with the actual numbers and then make sure that the number is somewhere in between 0.1 and 1000. That's kind of the generally accepted range. And if it's not, we can adjust the prefix on the units to bring that number within the desired range. So let's get started. We've got 212 millinewtons squared. So I'm going to square everything that's inside the bracket. So we need to square 212. So 212 squared is 44,900. And then the milli becomes 10 to the minus 3. 10 to the minus 3 squared is 10 to the minus 6. And then we've got newtons squared. What we can then do is take the 44,900 and factor out a 10 to the 3 because that's a little bit big. So it becomes 44.9 times 10 to the 3 times 10 to the minus 6 newtons squared. And then we're going to combine the factors of 10 together. So we've got 10 to the 3, 10 to the minus 3, and newtons squared. Now, normally we would kind of package that up to that 10 to the minus 3 up with the units. But since the units are squared here, we're not actually going to do that because if I was to write this as, say, millinewtons, as we normally would, millinewtons squared. The convention, if you see millinewtons squared, the convention is that that actually means that the whole thing is squared. And so it would be 10 to the minus 3 squared, and that should be interpreted as 10 to the minus 6 newtons squared. So I'm not going to write it as millinewtons squared because that's not the convention here. Okay, let's do part B. So we've got 52,800 milliseconds squared. So the 52,800 is really big. I'm actually not going to square that. What I'm going to do before I square everything is just combine that with the milli because that's 10 to the minus 3, and that'll bring us down to 52.8 seconds, and then we're just going to square that. So 52.8 squared is 2,790, rounding to three significant figures, squared, and then that is a bit big, so I'm going to factor out a 10 to the 3. And again, I'm not going to combine the 10 to the 3 with the seconds, because if I was to write this as milliseconds squared, or sorry, kiloseconds squared, it's not the same thing as 10 to the 3 seconds squared. So 10 to the 3 seconds squared is not the same as kiloseconds squared. And then we've got, for our last part, we've got 548, 10 to the 6. That's all within a square root or to an exponent of 1/2 milliseconds. So let's take the exponent of 1/2 inside the bracket. So we do need to apply that to both the 548 and the 10 to the 6. So 548 to the exponent 1/2, or in other words, the square root of 548 is 23.4, rounding to three significant figures. 10 to the 6 to the 1/2, all you need to do is multiply the exponent. So 6 times 1/2 is 3. So we've got 10 to the 3 milliseconds. 10 to the 3 and milli cancel each other out. And so we're just left with 23.4 seconds. That's our final answer for part C.